And what is that? That is actually very easy. This is some sort of let us say this is R 0. Okay. So, what does it mean what I just wrote? Okay. R 0 means the best or equilibrium position and R means the current position. So, if R equals to R 0, if R equals to R 0, your E bond, of course, it will be 0, right. So, you put R 0 here 0, it will be 0, but whenever you put something other than R 0, it will always be positive, it is a square, which means let us say an example, R 0 is 1.1, I put R at 1.2. So, we have to 1.2 minus 1.1 square into K, I will come what is K. So, it is a positive quantity, right, which means energy is always increasing, and this is the representation of the same thing. And this is the equation of a parabola. You can check what is it in Japanese, but the equation of a parabola. So, now the question is what is K? K is important because you know this there are single bond, double bond, you know this, right, single bond, double bond. Okay. So, what do you think that we want to increase the single bond length and we also want to increase the double bond length, which case we have to give more energy. What I am saying I will explain just a moment, I will erase this part. Let us say CO is not here, but let us say, and this is, yeah, the two bonds, let us say this one, and we want to increase, we want to make it increase the bond length. Okay. So, if we want to increase the bond length, we have to give energy, right, more, some energy has to be given. So, question is in which case you have to give more energy, single bond case or the double bond case, and that is actually K. K is called force constant, it is a force constant, and that is a measure of strength of the bond. So, if it is a double bond, K will be large, if it is a single bond, K will be small. It is a measure of the strength of the bond, force constant. So, this is the bond energy expression. And if we just I think I will erase this part, you probably know now. Okay. So, the first term I will write here, E bond is K into R minus 0 square. This is the first term we learned. So, what we learned till now? We learned the energy of bond, which is like this kind of expression, which is R minus R 0 square, and R 0 is the equilibrium bond length or the best bond length, and R is the value of the bond at a particular point moment. So, so what is R? R basically that, so you know that like let us say okay, I think this is like, I think this is something like this, if it is a tetrahedral 1.54 angstrom CH, this is optimum bond length, but in a protein your CH may be 1.6, possible, it is possible. In that case R is 1.6 and this is 1.54. So, this is for isolated system, this is ideal best, but it can be more, can be less. So, this is our definition of R and R 0, and K is the force constant, that is the bond energy expression. And it is very easy to plot also. So, if you plot, actually you will get E bond versus actually R, actually you will get this kind of expression, which is whenever you change from R, energy will always increase. Okay. So, I will come in a moment. So, this is the bond, but also your protein has For instance, let us say okay. So, it has this angle NH, NCH or NCC. So, we need to calculate the energy of angle also. What is the meaning? Meaning is that this is the angle, let us say it has some value, maybe it has the value theta. If we want to change theta to another value, again we need to give some energy, and that is the energy of the angle, basically you can say. Like bond, and so bond you have to stretch, give energy. Angle is something like this. If you want to shrink or increase, you have to give energy in the same way. So, it is very similar to this one. And it will be theta, let us say. So, this is theta, theta means angle, and E theta. E theta means the energy you have to give to change a bond angle. And here the expression is also, say I write K r here, and K theta is theta minus theta 0 square, same kind of energy expression. Is this clear? The angle part? Angle part is also the same, because in your molecule you have some angle between 3 atoms. Maybe your molecule is A, B, C, and this is the angle, right, theta. But during computer simulation, which we will discuss in a moment, your angle value may change. Maybe it will become something like this, it can increase. So, this is theta 1. So, going from theta to theta 1, you need energy, you have to give energy rather, and this is the expression, how much energy you need to give. Because during computer simulation, your structure will not be fixed, it will change. I will explain in a moment when I go there. So, your structure, your bond lengths can change, your bond angles can change, and whenever it changes, the energy of your molecule also will change, and this is the way to change for the bond part and for the angle part.